Hi, everybody. As always, I'm Michael Linky here at the Australian Institute of Architects, and welcome to today's Lean-In session. So as we edge towards summer, that threat of another significant bushfire season is yet again among us. So today's Lean-In session is going to focus on how architects can develop more robust residential buildings in bushfire-prone areas across Australia. We're going to be looking at how we can minimise loss and how we can reduce risk. So we're going to look at the factors that were at play in last year or earlier this year's tragic bushfire season and look at how we can build back better. So in today's session, I'm really pleased to announce that we have two speakers joining us. Not only are we being joined by Michael Dawson from the Australian Steel Institute, we're also very fortunate to have Dr. Ian Weir from the Bushfire Building Council of Australia. We'll be looking at steel material systems, solutions, strengths and opportunities. And we'll also be discussing the considerable opportunities for architects to design solutions for clients in those very high-risk bushfire zones. Now, today's session is being recorded, so if you have to leave us, during the session, don't stress. A copy of the recording will be made available on our dedicated Lean-In page later on this afternoon. Don't forget also that the chat box down below is your friend. So if you have any questions at all for our speakers, pop your question there, and then at the end of the session, I'll go through these questions with Michael and Ian too. So a bit about our speakers. Michael Dawson has over 20 years of experience in the built environment. He's working in senior management and strategic roles. He's got 6 years of consulting in sustainability and management. Michael has a Bachelor of Education, a Master of Business, a Master of Commercial Law, and he's really focused in that area of study on environmental law, climate change, and also construction law. Dr. Ian Weir is obviously known to many of you. He's a consulting research architect with the Queensland University of Technology, and he's a director of Ian Weir Architect. In both roles, he receives commissions for designing bushfire responsive houses, and some of his examples include obviously the Carry Firehouse and H House, both in Western Australia. He's a member, of course, of the Bushfire Building Council of Australia, where he's an expert advisor. So Michael joins me now live from Melbourne, and Ian joins me now live from Brisbane. Gentlemen, welcome to the program and great to have you with us.
Thank you, Michael. And I guess just off the bat, I'd like to apologise for my internet issues last time. But the great news is, as Michael mentioned, that we have Dr. Ian Weir, who's volunteering his time to join in today. And Ian's, I've got a strong background in steel and the building sector, but Ian's also got a very strong background that will add to this conversation we're having, particularly as he was a co-author of AS 3959. Ian spends a lot of time in media advocacy in this space, internationally as well, with in New York and overseas, and works really closely with bushfire engineers and the Bushfire Building Council of Australia. So we will get started, and as Michael said, it is a good time to reflect. It seems so long ago since we had the bushfire disasters last summer, with everything that we've had on our plate.
So greetings all, this is Ian. So Michael and I have rehearsed this to a certain extent, and I'll be ad-libbing to some of Michael's comments, and then I'll be addressing 4 or 5 slides specifically related to the Bushfire Building Council of Australia. And I'm hoping together we can really give you some clear pathways forward in innovating in the bushfire space.
What we'd like to do is just kick off with some key headlines, key points at the start. And quoting Albert Einstein, obviously, we cannot keep doing the same things and expect a different result. So this is a big opportunity that we have at this time to look at changing things up. I guess an illumination of ideas for non-combustible building materials that can work with products such as steel, as seen as being really critical. There is a really strong need to ensure that the building has a complete barrier to ember attack. It's all of the evidence is pointing towards that, which we'll talk about today. And it's really important to have strong, durable materials suitable for changing climatic conditions. And one of the great opportunities is, and I'm sure Ian will elaborate on this, is that if we design in fire-resistant buildings, then at the same time we're going to ensure that we've got a building that can withstand other climatic change conditions that we're all facing as well.
Yeah, that's right, Michael. I mean, the way I look at designing for bushfire is that really you're designing for an accelerated weathering event. So if a building is designed well for bushfire, then it's going to just have straightforward durability, in its kind of DNA.
Yep. So another key point that we'd like to talk about is taking that long, full life cycle view, which we'll elaborate on more. It's the long life of the building and the structure is so important. And I'll move us on to just give a quick outline on the topics. So I'll talk a little bit about the ASI just briefly. We'll touch on, introduce the climate that we've found ourselves in at this time in history and what's generating bushfire risk. We're going to talk a little bit about the building codes and regulations, and Ian also has some strong expertise in this area that we'll add to the discussion. We'll move on to touch on fire resistance in buildings and spend quite a bit of time discussing light gauge steel solutions and the National Bushfire Standard before we finish up with some general principles and open it up for questions. So a little bit about the ASI. We are the Peak Steel Industry Association, and we're quite proud to say that during this COVID period, we have had an increase in membership, which has been great. Something that would be of interest to the audience is that we we've got a strong focus on quality and looking at compliance systems, particularly with the National Structural Steelwork Compliance Scheme and AS 5131, which is the new standard for steelwork fabrication and erection. So we see that as important because Australia is was one of the only countries that didn't have a standard for steelwork fabrication and erection until now. We have a sustainability charter for our members, and there is we put a lot of work into education and learning programs for our members. Just to give you a cross section of our membership, as you can see there, it does cover the complete construction supply chain. We do have some architects that are members, but certainly we cover the full gamut from steel manufacturing to distribution. We have a lot of members who are downstream manufacturers and roll formers through to the service end, and of course professionals in engineers and architects. We've found in this era too, just to finish up on talking about a background on the ASI, that certainly online learning, e-learning as we have there on our website, and access to technical information is becoming really important, and short courses as well. So just in terms of, I guess, a lead into where we find ourselves, as we all know, the climate is changing, and it is warming, and it is having impact on our environment and the built environment as well. So it's just, I guess, important to understand that this is an issue that's not going to go away, as I'm sure we're all well aware. If we consider the history of, I've just got a summary here of major bushfire events, and as you can see there, sadly, lots of lives that have been lost in bushfires, and many homes that have been destroyed, and particularly the terrible bushfires of last summer. But certainly what we're seeing is very large areas of land that are getting burnt out as well. So we'll just talk a little bit about the risks factors, and some of this won't be new information to you, but certainly it's really important to consider the vegetation and the building materials around the site, and obviously the combustibility of those materials is really a strong risk factor. Interestingly, fire runs quickly up hills, and as we saw last summer, it does spread very, very quickly, and the ember attack, the spread of embers across a fire region is a really significant risk and issue as well. So just in terms of how buildings burn, and Ian would probably have some comments on this, but the key issue, the major cause is that of building damage is ember attack. So it's understood to be that around that 90% level where the major cause is embers that are causing the building to eventually get damaged and ignite as well. Ian, would you have some comments on that?
Yes, so it's been known to be around 90% for quite a few years now. I recall that percentage at the time of Black Saturday, and it seems to be the same statistic for Black Summer. So we also know that around 90% of houses are lost within 100 metres of bushland, which is not surprising really when we think we're talking about bushfire. So what is happening when we've got 90% being lost from ember attack of houses, but most of those houses actually being close to bush? What we have to imagine is, or visualise, is the ember attack is attacking or igniting whatever is combustible, both in the immediate landscape around the house, i.e. bush and leaf litter and wood chips, for example, and mulch. But also, of course, the combustible elements of buildings themselves, whether they be window sills or the interior aspects behind the outside cladding. So that might be the structural wall framing, the timbers in the roof space, and so on. So we're not just talking about embers intruding in through a building into the interiors of buildings. We're not just talking about embers getting into the unseen areas like the wall and roof spaces. We're also talking about embers igniting the immediate landscape and elements around the building, things like cars, caravans, kayaks, stockpiled timber, and so on. So that's the trigger for the house loss is the ignitions from ember attack. And so, relatively speaking, direct flame contact, even though we might see quite provocative images fed to us through the media that give us the impression that we're talking about direct flame contact, still the statistics are 90% are actually ember attack. And then the houses, of course, are burnt, to the ground, and in some occasions ignite the neighbouring house.
Okay, so we'll just move along and talk a little bit about building codes and regulations. And as it will be well known to all of you, the National Construction Code Volume 2 is a key reference which mandates the safety of building occupants via two approaches: the performance solution, which we'd like to talk a little bit about today, and also the deemed to satisfy option as well. So there are two deemed to satisfy methods complying with the NCC. One is the NAS standard, which we will talk about at a little bit of length shortly, and of course the other one is AS 3959, of which Ian is a co-author.
Yes, it's quite understandable that for many of you in the audience, you might assume that AS 3959 is the pathway for certification of compliance. AS 3959 does have some history in this space, so it's kind of a brand, but it's not the only way of meeting the requirements of the National Construction Code. The AS 3959 is actually in two parts. The first part is the bushfire attack level assessment methodology, and the second part are the construction levels to meet those BAL levels. What we've found is that in various state governments, particularly New South Wales, they've written planning for bushfire protection for those of you in New South Wales, and that document now has the bushfire attack level assessment embedded within it, within that planning document. So I guess the main points here is that AS 3959 is not the only pathway for compliance. It works on a particular paradigm. We'll talk about that a little later. Nash Standard works on a different one, but please be mindful that there's the performance statement. So Michael, perhaps if you just discuss that and I might fill in some more.
Sure. So I've highlighted there a reference, and I should point out that with this presentation, which we'll provide, there's we'll provide all of the references as well at the end of the document. But what I've, as you can see on the screen there, there is a bushfire verification handbook, which has been put out by the national, under the National Construction Code, put out by the ABCB, and there are in that there are some, if for those that don't know, there's some good references for these performance solutions around designing the building for ember and radiant heat attack, and assessing the performance approvals. So we've put that up there as a reference. Ian might have a couple of points to add to that.
I think the main point, Michael, is that the performance statement in the NCC is something that you should all be cognizant of and understand that that is really the best pathway for innovation. For those of you that are looking at doing something out of the box, not a DTS solution prescribed in either of the two standards we've mentioned, that is the pathway. And of course, there's the requirement in there to use consultants working backwards from a building certifier to sign off on it, and the likelihood of needing fire engineers to support your alternative solution.
Thanks, Ian. So that brings us to state governments and their controls, which are predominantly around setting up the bushfire-prone areas, as most of you would know, which have some subtle differences across the country. But a key point here is, of course, is that the state government legislation still is underpinned by the National Construction Code performance requirement, which we've listed there, and also AS 3959 as well. So Ian, I'm not sure if there's a couple other points you might want to add.
Just on the mapping of bushfire prone areas and the relevant buffer areas and so on that some of you might be familiar with, that is going to be unified into a single methodology. And the first state to come online is Queensland. Next will be WA, and then I think Victoria, and then pretty soon all states where bushfire building is relevant will have a unified mapping methodology and style.
Thanks, Ian. So that leads us on to some information. I thought it'd be very relevant for us to have a small section here on the Bushfire Building Council of Australia. Urge you, if you haven't already, to have a look on the website at what they do. But of great interest is that they are developing a 5-star bushfire resilience rating system, which will be designed around or established homes and also for new homes. And the rating system looks at the likelihood of ignition. And I'll let Ian perhaps add a few points, because Ian works quite closely with the Bushfire Building Council of Australia.
Yeah, just briefly, the Bushfire Building Council of Australia was started about, I think, 7 years ago. And it consists of members such as Craig Lapsley, the first and last Fire Commissioner in Victoria, fire engineers, an architect in myself, and other bushfire risk experts and firefighters. And it's not-for-profit organisation, And together we've spent collectively many, many years on committees, such as the one for AS 3959. And so we're right across the gaps in the regulatory framework in Australia, in most states. So this is a comprehensive way of assessing the risks of houses using the methodology for determining what the fire event is in the National Construction Code. So it's aligned to the National Construction Code verification method. So a star rating system applied to both existing houses and new builds. So we can go to the next slide if you like, Michael.
Sure.
Yes, so one thing, for those of you that are familiar with AS 3959, particularly building to flame zone, you might have noticed the reference in that standard to other AS standards, particularly 1530 Part 8, Point 1, Part 8.2. None of the methods, these other standards I mentioned are actually laboratory testing methodologies, and none of the laboratory testing methodologies that we have in our regulatory framework actually test for ember attack. So so that's just to indicate that we've got 90% of building loss from ember attack, but we have nothing within our current standards and regulations that actually responds directly to any kind of scientific knowledge we might have on what embers are actually doing. So the BBCA is advocating for other forms of testing to acknowledge that high percentage of loss. We view that actually building in bushfire-prone areas, even up to Bell flame zone, is actually a relatively easy exercise. Should be much easier than it is now. And the first principle is non-combustibility, using non-combustible materials, whether they be masonry, whether they be steel, non-combustible materials, so fit for purpose. We see that this is an aesthetic issue, not just a scientific problem. That we need architects to deal with innovating in this space to for the end users, and we acknowledge that what's driving this is people want to live in the bush. So we're not about separating people from bush, unlike a lot of other forums and conferences and so on. So this is about actually engaging with that kind of law of attraction, if you like, that people want to be close to nature. There's a lot of health benefits, mental and physical, in that, and so let's actually adapt for that desire, that need. So we do base our work on and our design, and our projects on science. So a key member of the BBCA is the CSIRO representatives of the fire research section there. Next slide. So we're presenting a couple of examples here. So we had the Steendijk house there just before, which is a wonderful house. This is a house myself and I designed for a professional firefighter in Western Australia. So there's nothing super high tech about this house, designed for Bell 40, entirely non-combustible. Here the glazing is all protected by lightweight stainless steel mesh, which protects it slightly from ember attack and projectiles, but also a bit of radiant heat. And if the windows are left open, then of course you've got that protection from embers. So just designing for robustness, resilience, and non-combustibility. And it's kind of not that difficult. The difficult bit is actually integrating everything elegantly so that people aren't spending a lot of money just on the bushfire features. So having the shutters, for example, doing something much more than just working once in a lifetime or once in a bushfire event, but providing shade and insect control and so on. Next one, Michael. These two images are images I took myself immediately after Black Saturday, or actually a couple of weeks after Black Saturday. And it just spells out really clearly the image on the left. It doesn't matter how big your asset protection zone is, the clearing around the house, embers can travel from a long way away and get beyond a non-combustible cladding. If there's gaps greater than 2 millimeters in that cladding, that roof sheeting, that will ignite interior elements, whether they be the wall framing, roof framing, and so on. So when you don't have a second line of defense or a third line of defense, and you've got large gaps in your exterior, which might still be non-combustible, you can still lose a building. Image on the right just really spells out that we are fed images of mass destruction of houses as architects, and we tend to believe or misunderstand that buildings can't survive bushfires very well. It doesn't matter what you do. But this image actually is a house that obviously is burnt to the ground, but it wasn't ignited by flame contact, it was ignited by embers, and the house subsequently ignited the trees around it. So these are all elms and oak trees, and on the far side of the trees, on the landscape side of the trees, they were completely unburnt. So it's the house that actually ignited, singed the trees immediately around its perimeter. So this image on the right is to encourage you to think twice when you're fed the very provocative images that we get during and after major bushfire events. And just the last slide here, just to acknowledge some really important precedents. Glenn Murcutt's house in the Blue Mountains, the Simpson Lee house, been in 3 fires, was affected by Black Summer. The deck was actually singed a bit. It's a hardwood, I think, Class 1 durability timber boardwalk there that enters into the house. That was singed a bit. I've had a chat to Glenn about the house. It performed beautifully as it did in the other 2 fires. The Montecito residents, Montecito area, Montecito Canyon, you may have heard of that in the news. It's been in 2 major fires in California. Really extraordinary house by Tom Kundig here, and a wonderful quote where he's recorded as saying he wanted to build a house that didn't contribute to the fire front. And in my mind, that is exactly the kind of paradigm that we need to be addressing adaptation in bushfire-prone areas, understanding that bushfire does not discriminate between buildings and bush. When the fire danger index goes up, so too does the ignitability, the likelihood of ignition of timber, because timber is timber, whether it's in the bush or in the landscape or in the building, and its propensity for ignition goes up as the fire danger index heads up and goes through extreme into severe and then into catastrophic. Your timber decking will increase in its likelihood of ignition as the FDI goes up. Thank you, Michael.
Thank you. So we'll just touch on a few key points on fire resistance for buildings, and this is where steel does have an important role to play. So as you would know, it takes a lot of heat for any impact on steel in terms of its integrity and its performance as a structural component of a building. Bushfires do have a lot of heat, but they do move through quickly, just in seconds and minutes. So one of the keys is to really use non-combustible products to build in a passive system, so layers of resistance, if you like, to prevent the fire from getting to peak temperature. And as Ian said, the key is to prevent ignition of the building. So steel does play an excellent role in that. There's a chart there that shows you in terms of the type of heat that's needed before the structural integrity starts to get impacted. But one of the critical point out of this slide is really building in passive protection, using at the start an outer shell that protects also not only the outside of the building, but fire getting towards the inside of the building as well. I'm not sure, Ian, if there's anything else you'd like to add to that.
Well, as architects, we're taught and led to believe that large section, if the cross-sectional area of a timber element is large enough, that's going to be better than steel in fire. Now, that is true when we're talking structural fires. We're talking bushfires, and we're talking about a really quick event, seconds, minutes. We're talking around about 800 to 900 degrees. When you're talking a structural fire, you're talking fires that are being fueled by nylon fabrics, petrochemical things, and they're contained within a space. They are burning for a long period of time. So you've got the duration and the likelihood of greater temperatures. So we're talking about the first element of preventing ignition, not just on the first line of defence, the cladding, but the second line, and with the Nash standard, as Michael and I will talk about, there's even a third line of defence in there.
Yeah, and the key thing here is building in time. So it's increasing safety for the occupants by having those various layers of fire resistance. This shot just simply, well, not simply, but it shows quite a ferocious fire that's underway, which obviously there's ignition outside the building, and there's obviously materials inside the building that have ignited. But as you can see, adjacent to that, there's a building that at that point in the fire is not impacted. So again, this gets back to that time element of allowing time for occupants to get out of the building, but also hopefully for fire authorities to extinguish the fire.
Yeah, and so obviously these buildings weren't impacted by a bushfire, but nevertheless there's been an ignition of combustible elements in either the roof space or the furniture or whatever it might have been. And that is the event that is that in-between phase between the images we see in the media of the totally destroyed house and the ignition from, we know that 90% is from embers getting into that combustible space. So it's a really good image to visualize when we're thinking of designing for bushfire.
Thanks, Ian. So that takes us on to light gauge steel solutions. So we're just going to talk a little bit about the products that are available and lead into the NASH bushfire standard. So with light gauge steel, as many of you would be aware, there's a range of options and multi-use capability of steel products to be used for various design elements in the building. Cladding, purlins and girts, steel working with concrete, internal partitioning, and so on. And I think one of the key points here is that light gauge steel also works very effectively with heavy steel as well. So if there needs to be an extra load bearing component in there, that mix and match of the various steel structures or products works really well. So just touching on, just quickly, another standard, AS NZS 4600 for cold form steel. Just for those that don't know, alert you to the fact that the design methodology in steel buildings for cold form sections is based on these members being protected by fire resistant barriers. And that's the extra layers that Ian's talking about due to the fact that there's a high exposed surface area to mass ratio. And there's an image there of a blue scope true core frame as well. So moving on to the NASH bushfire standard. So we'll just talk for a few minutes about this standard before we wrap up with some summary. And as you can see, the image there is the full-scale test by CSIRO in Mogo, New South Wales, which has been used for the NASH standard. And after that test, the internal framing was still in working condition. So the standard itself has been developed to meet the performance requirements of the National Construction Code. Obviously, we're talking about non-combustible construction, and it's referenced alongside AS 3959 as well. It's a DTS solution, and it covers steel frame houses with steel roof cladding and non-combustible walling.
So yeah, so that test is uses propane gas, which is actually slightly more hotter than bushfires, and is a full flame immersion test. So if your innovative design passes that test, a lot of the systems don't need to pass the other tests. So it's a full simulated bushfire attack, three-dimensional, and all sides of the building.
Thanks, Shane. So this image here is still talking about the NASH standard. So starting with the building envelope, which is a really critical part. the key message here is having that building envelope structure that doesn't allow ember penetration to get inside the building. So it's an outer shell, if you like, to provide that protection with non-combustible. A key is non-combustible cavities, as you can see within that roof area there as well.
Yeah, so a key distinction here between NASH and AS3959, it's quite a big distinction. If we don't have an image of this, but if you were to visualize AS3959, it would just have the outer envelope, the very outer skin is what AS3959 deals with. NASH, for example, says you can't have platforms in your roof space because it's actually saying that roof space needs to be kept non-combustible and to not encourage people to store cardboard boxes and so on, which is really common and a real major contributor to house loss. So it goes right through to including the gyprock lining in the ceiling and the walls and even the floor lining. So this diagram actually is showing the key kind of paradigm that NASH is working with, as opposed to AS3959, which is just the outer skin, and therefore AS3959 tries to do a lot. It tries to stop everything coming through in that outer skin.
Thanks, Ian. So the NASH bushfire standard, there are two solutions which I identified there for BEL 12.5 to BEL 40 and the BEL FZ. And windows and doors to AS3959. And as we said, it's referenced in the National Construction Code as a DTS solution and has been since 2015. I guess a key point also, as many of you would be aware, is that steel house frames are built using standard building practices and standard materials. This image here shows you the NASH bushfire standard with the roof detail, with the steel roof framing battens, and of course all the steel fixings there as well. And as we said earlier, the real key here is establishing that complete barrier to stop ember entry using non-combustible steel materials.
Yes, so we've got the diagram here for BEL 12.5 to 40. For those of you familiar with flame zone for AS3959, you might be aware of the generic roof systems that are described diagrammatically in AS3959. We don't have the diagram here for NASH flame zone, but it's quite a bit simpler. And while I haven't done the cost comparison, I would have thought it's significantly cheaper to build to the NASH standard compliance with flame zone. That is, of course, if you're building, this typology of house, which is kind of your traditional typology.
Thanks, Ian. So there are just on the horizon, we thought we should just mention there's a couple of, or several, I should say, proposed changes that are expected that'll be referenced in the 2022 updates for the National Construction Code. And that is storage platforms and ceilings won't be allowed for the reasons that we've talked about. Give solutions for tiled roofing for BEL 12.5 to BEL 40. Extended roof pitches and extend solutions to cover cathedral ceilings. It also covers roof skylights and windows, and clarifies the requirements for air conditioning and service ducting. So we're getting towards the end of the presentation. We'd like to just perhaps talk for a couple of minutes and wrap up on a few of the key themes that we've been talking about to date. So the key principle is that for bushfire resistance, non-combustible materials and using layers of defence in the building structure using non-combustible materials is really important, and steel can play a really effective role in that. We've mentioned that the ember attack issue is critical to form that defence, as approximately 90% of buildings are damaged because of ember attack. The architect's role is super critical in the design, of course, and creating opportunities to use, as Ian was talking about, fire engineered performance solutions. So thinking about other opportunities that can take us further on this journey to build structures that are fire resistant. Steel building products have a long life cycle, as we know. So, and I think a point that I'd like to raise is that steel can be really used in a sustainable way. Steel, as I said, has a long life. Steel is preeminently recyclable, and it can be reused. And of course, steel has itself, in the manufacturing of steel, it has recycled content that goes into its manufacture. But a key thing is that it's non-combustible, and it does add to that long life approach. And on that, prior to this presentation, I had some discussions with David Cox, who I think is quite possibly listening in from Cox Architects. David's philosophy, I think, is right, is just taking that balance sheet approach. So it's the long-term game that we're really looking at, building a structure for the long term that will withstand, I guess, climate change and the impacts of not only fire but also the other elements that we're increasingly seeing with that. So I've got a reference there that to point you towards some good articles that David has put out on that. So fire engineered performance solutions can provide greater resistance, and as we've said, build in time, so that if the fire at front is coming through rather rapidly, it can build in, I guess, time and prevent components of the house from igniting and leading to a complete ignition of the house. And as Ian said, planning for the building materials around the area of the property, not only the property itself, but there's very strong evidence about how fires hop from combustible materials or items that are laying around the site itself.
That's great, Michael. I guess I'd like to follow on from that with a real sort of call to action. You know, architects, I think we undersell our innate understanding of human behaviour. And so we need to really visualise how people are going to be living in these houses, where they're going to be storing stuff that might be a real problem in a fire, how they're going to behave during an event. The BBCA, we believe that houses should be able to be designed relatively easy to protect themselves in a fire. AS 3959 kind of encourages people to stay with the house to increase the likelihood of a house surviving. So, you know, what paradigm are we going to be working with here? My view is that we want to give people maximum choice, so that they're not, you know, going through major conniptions on what to do during that extreme fire event. So, taking out the responsibility of having to stay with their house to protect the house, I think is a good pathway of thought. I think I see in steel not just sustainability generally and recycling, but also design for disassembly. This is not my idea. I mean, Mercot's been working on that for decades. And the cost not just being about you know, the long-term equity, but also, as I mentioned before, optimizing. So if we're using one thing for a bushfire, then, and if that one thing is going to cost $50,000 just to tick the box for flame zone, then let's make sure it's going to do a lot more things than just provide protection to the building during a fire event. The lines of defense, I think, is a really key principle, design principle, thinking of all the lines of defense, ultimately between a person and the fire event. And I think in closing, my main sort of comment is that we don't have a bushfire problem at all in Australia or anywhere for that matter. We have an ignition problem. And it's really important to understand that people want to live in the bush. Our job as architects is to connect people to landscape and landscape systems, not to distance them, and to understand the bush is not the problem. The ignition of the houses and the immediate things, stuff, landscape around the houses is the problem.
Thanks, Ian. Just getting towards the end of the presentation now, and I think I've probably covered these points, but obviously steel is an excellent material to consider for the design of bushfire-resistant buildings. And I've really mentioned all of those points, but perhaps a couple I haven't. Design flexibility, obviously with architects, it's critical that the creativity and the opportunity to look at different designs is brought into play, and steel does play a very good role in providing that opportunity. A lot of the other points there I've mentioned about it's non-combustible, it doesn't add fuel to the fire, obviously a very strong and durable material. And the other points I think I've mentioned. So we'll, just to wrap up, I thought a couple of good quotes here from people that you may know. Ken Watson from Nash. Ian and I like this one. Homes in bushfire-prone areas which resist ignition, add no fuel to fire, remain strong and secure in all conditions, represent better value for owners and the community as well. And one from David Cox is steel and other non-combustible composite materials working together. So looking at just that different mix and the alternatives provide an excellent fire-resistant solution. So bushfire protection does start with good design and a selection of materials and building systems. So we hope that you've got a little bit out of this presentation today that's of value, and my details are there, and I think I provided Ian's up front. We will be very happy to provide this presentation to the Architects Institute of Australia. We do, thanks again, Michael, we do appreciate this opportunity to talk today, and you'll also note that I've added quite a few resources that you can flick through if you need more material when we get this slide deck out there. So I guess we'll open it up to any questions.
Absolutely. Thank you very much, Dr. Ian Weir from the Bushfire Building Council of Australia, and of course, Michael Dawson from the ASI, the Australian Steel Institute. Great to have you with us. Let's start off, let's talk. We've had a number of questions come through the chat box, and I will remind viewers, if you are watching and you do have any questions for us, pop them into that chat box, and we've got about 10 or 15 minutes or so. Let's go through them. Let's start off then talking, gentlemen. First of all, we've talked a lot in this session around Class 1 buildings. We've talked a lot about Class 10 buildings. We have a number of members, and a growing number of members, actually working in that aged care facility development space. We've got members working in development of dementia units. We've obviously got the RACF, the Regional Aged Care Facility work that we're doing out in the regions. And an interesting question that's come through from Sue. She talks about being very interested in Class 9C, and of course that's the ACF, the Aged Care Facility part of the code. What are your thoughts on buildings, especially many, like she says in her chat, many regional aged care facility buildings are indeed built very close to bushland in the regions? What are your thoughts on that?
Well, I guess to open up on that, a lot of what we've talked about today, the principles definitely align with aged care buildings. We're talking about, I guess, larger buildings. We're talking about units that are close together. So again, a lot of the solutions that we've talked about, I think, are ideal, and the standards that we've talked about, there is a really good fit and a strong role for steel to play in that, in those buildings. So I'm not sure if Ian's got some other comments.
Oh, Sue's actually has put something on the chat, which is interesting. And she talks about that she loves the fact that the aim is not to separate people from the bush. And her question, really to be more refined, is how can we apply this to seniors who would obviously defined as a special hazard category?
Well, I think the first thing is that there's a lot of kind of misunderstanding as to what in the bush is actually the problem. And the best term is actually available fuel. So we can certainly keep people close to trees and close to tree canopy and close to many plants. And I'm here picturing indigenous native species, not exotic European species, and at the same time minimise the fuel. And there's an important new diagram in the 2018 version of AS3959 on page 17 that makes that really explicit. So for those of you that have the 2018 standard, it has some significant differences to the standard that came out in after Black Saturday. And one of the most, as picked up by the WA state government, was the diagram on page 17. So please have a good look at that if you've got access to that. If you haven't, I can send you the diagram. The other thing, it's a no-brainer that we should apply what we're doing for our class 1 residences to aged care. It's just a no-brainer. And the other thing, of course, is to be mindful of the human behaviour aspect and the capabilities of residents to, whether it's last minute evacuation or the need for them to stay in place and so on. So there's a much greater spectrum of issues at play in the aged care space because of the, the variable capabilities of people that we're talking about in that situation.
A question's come in from Jeremy on the chat, and he's quite intrigued just in relation to your mention of bushfire shutters. You talked about the shutters, of course, that you used on your own project. Care to expand on that? Talk us through these bushfire shutters and the requirements, I suppose, of them and the implications for that they have, I suppose, on window and door requirements.
Well, most of the flame zone shutters, so if we're talking flame zone, there'll be some people in the audience today that would have specified flame zone shutters, I'm assuming. They're either a roller system or a hinging door system, and they're generally steel, stainless steel, or some are clad in colour bond. And they will most likely have passed one of the standards that I mentioned, one of the actual furnace tests, laboratory furnace tests, which was 1530 part 8.2, I think it is. And the roof systems in AS3959 have also passed that similar test. So what we're talking about for flame zone is shutter systems that have actually basically meet an FRL rating. So are achieving similar kind of fire resistance features as what a fire door might do in a commercial building. When we're talking, if we're talking the language of AS3959, when we're talking lower bushfire attack levels, so anything BAL 40 including and lower, then there's much, much greater flexibility. In fact, you can make your own shutters. You can make them out of fly screen as long as it's metal. And they can be very, very affordable. Also, since I built the Carry Firehouse in 2014, there's now many, many tested window systems out there to BAL 40, including BAL 40, that don't need screening on them, don't need shutters on them. But one thing to be mindful for those that are working at that high end BAL 40 and flame zone is that there are limitations on the sizes of these elements simply because the test laboratories only have certain sizes for testing certain sized elements.
Okay, thank you for that. Let's talk about shipping containers. They're all the rage. A lot of people like to, sort of buy an old shipping container and then take it up to the country and plonk it on a bit of land and that kind of stuff. And Janet asks on the chat, this is an interesting question about the use of shipping containers to provide enclosed shells. According to some councils, apparently shipping containers don't meet AS 3959 because the structural element can be exposed to flame. Have you got any questions or response to that statement?
That's not correct unless we're talking flame zone, but even that could be used. It's perfectly fine in flame zone as long as there's an insulation kind of layer behind it and so on. As a principle, as a design principle, a fully enclosed, I've presented the house by Tom Kundig, made out of exactly the same stuff, Core 10 or Oz 10, WR 350 as we call it in Australia. That's a great material that you can weld on site and get a completely hermetic seal and stop all the embers coming in. Yeah, absolutely no problems at all. Often there's a lot of aesthetic kind of pushback from local governments, which is a bit justified, but yeah, no problems.
True. With a couple of minutes left, I suppose one of my final questions to you both is really, I mean, it's now almost coming to the end of October. We're now, heading into summer. What are your thoughts? What are your predictions? What are your concerns over the state of the 2020-2021 bushfire sort of life cycle? What do you see for the country for the next 3 or 4 months?
Yeah, it's a good question. I guess one thing is a hope that we don't. We've now had this period with some rainfall across the country, that we don't have some complacency set in, because it just only takes a few weeks of that heat to really set in, and we've all of a sudden then got bushfire risk on our hands. So I guess I hope we don't have complacency. It's been such a tough year for everyone, with to come out of those disasters, bushfire disasters, and then have COVID hit us, and so I think that. But I would just like to think more on the side of opportunity. Just what a great opportunity that there is, that we have in front of us to look at, as we've been talking about today. Just how do we do things better, and just continue to learn from what's happened from these big disasters. So.
And we see, it looks to be, at least anyway, predicted by the weather experts and the precipitation gurus, that there's going to be more rain on the way because of the La Nina effect over the country. So it might be some form of relief as we move into the summer break, of course. Ian, what are your thoughts on the state of the country for the next sort of quarter?
Well, look, I'm not a climate predictor, but I think something I think that we don't do enough of as architects is inform our clients how to use them, how to use the buildings. And one of the things that I really advocate for at any opportunity, and I'll take this one, is to broadcast to clients in particular the importance of understanding what the fire danger index actually means, and how that increases the likelihood of ignition of the landscape around their house, and the elements around their house, and the timber wall framing behind the cladding, and so on. Because as the FDI goes up, as I said before, everything dries, and it's not about heat, and it's not about wind, it's not about those meteorological effects alone, it's about underlying kind of drought conditions. So I doubt that we'll get something as extreme as we had in Black Summer, because we don't have such a ramped up underlying drought condition, but be really mindful when we do start to have that next time. But I mean, we lost 2,600 houses in the last fire event. It's actually nothing compared to how many houses we've got out there in the bushland interface around Australia. So, it can kind of happen anywhere, kind of any time. So, it's something that we need to be really mindful. Even if we're not building necessarily in an area that we might think is extremely bushfire prone, there's still the propensity for it to happen, and it's not that costly, and it's not that hard to do. So, Michael's laid out all a really straightforward first principles today. So, and it's all there, all the information is there.
Yeah, absolutely. One thing that I'm taking away from this is we talked about Australia not having so much as a fire problem as an ignition problem. And I've never really thought about it from that angle before. So thanks for opening up our sort of minds to that concept as well. Let's leave it there. Dr. Ian Weir from the Bushfire Building Council of Australia, and of course, Michael Dawson from the Australian Steel Institute. Thank you so much for joining us today. It's been absolutely fantastic to have you. And of course, to everybody on the call, we will make this recording available on our dedicated Lean-In recording page together with the PowerPoint presentation. So you can go through it again in your own time. Don't forget, Michael's always keen to hear from you. So don't forget, his email address is on the screen, michaeld@steel.org.au. So if you have any further questions around steel design, or you want some advice, guidance from either him or Ian, then by all means do reach out to Michael and he can have a chat with you. So thanks to you, gentlemen. I hope that everybody on this call has found today's session beneficial, and I'm sure they have. Now,
thanks, Michael.
Absolute pleasure. Great to have you both. Now, next Tuesday, you're going to be doing something very different. I'm actually going to be taking you all on a completely different Lean-In, and we're going to be taking you on a virtual tour. We're going to virtually visit the University of Wollongong Sustainable Buildings Research Centre. We're going to be working with that team behind the centre. So we're going to be talking to Senior Professor Paul Cooper, who's the centre's founding director. We're going to be talking to Dr. Craig McLaughlin, who's their research facilities manager, and they're going to provide us with a guided virtual tour of the building. And they'll be looking at the building certification systems, their biophilic references, the main operation of the building, so their green walls, their communal areas, their inbuilt tech, so their thermal slab, their ground source heat pumps, their transpired solar collector, green IT systems, and other key aspects of design that actually earned that building the full marks in last year's Living Building Challenge Award. So keep an eye out for that. That'll be coming through on Monday into your inbox. So join me for next Tuesday to do a fantastic virtual tour of that centre down in Wollongong. And if you're a fan of sustainability, then by all means, you'll love it. Anyway, that's it for today. I hope you've enjoyed today's lean-in session and got something out of it. As always, I've been Michael Linke here at the Institute of Architects. Thanks so much for joining me, and I look forward to seeing you again on Tuesday next week for our virtual tour. Until then, do stay safe. I'll see you all soon. Thanks.